Alright, so here are some steps to graph polynomials by X-Intercepts. First thing is to question, is it factored? So I have a problem here. It is in factored form. I have binomials there. The second thing is to get a basic graph. To get a basic graph, I'm going to do this. This is just an x. Notice this one, eventually, if you expanded it, it's x squared plus 6x plus 9. But I'm just more concerned about the highest degree, so this will become an x squared. And then over here, this one will become an x to the third. So my basic graph, this is a 1. I can go this direction. When you're multiplying, same base, you add the exponent. So 1 plus 2 plus 3 gives us 6. So our basic graph is x to the 6th. Well, x to the 6th, this isn't even. Think back to the easiest even you know. X squared. That's an even, right? And it looks like this. So these arrows here are going to give us kind of a start and an end point today. So it's already factored. We've got a basic graph. Let's talk about multiplicity. Did I spell that right? Sure. I'm going to have to use the zero product rule. Well, what is the zero product rule? Essentially says that you set each of these equal to 0, because one of those has to be 0. So if you did zero product rule, you would get x equals 0. And here you notice that you're writing this expression twice. Because do you want to solve the same problem twice? No. So I have x equals 0. Class, if you solve this one, what do you get? X equals negative 3. Notice I'm not going to write that twice. Does that make sense? And it'll make sense actually after today's lesson. And then the last one, your red marker. If you solve this, x is equal to what? 1. So let's go ahead and go through its highest degree. Here, x is to the first power. Right, we already got that. Here, this highest degree is 2. And here, the highest degree is 3. And then I'm just going to use my chart. Class, is this odd or even? Odd, we're going to shoot through. Odd or even? What do we do at even? Kiss. And odd or even? It's an odd, so we're going to shoot through. For right now, we don't need the transformations, and then we're going to graph it. Graph it. I'm going to use a pencil just in case you need to erase, or I think it's a little bit easier to round out things. Okay, here's the start and end. Do you guys see that? Do you see how it starts up and it's going to end up? So you can go ahead and just put 2 arrows, starting and ending. I guess we should have put these values first, so I'm going to put in x equals 0. X equals negative 3. So negative 3, 0, and 1. And I'm going to have to start through this arrow. We're going from left to right. And I need to end up through that arrow there. So I'm going here and I'm approaching negative 3 first. So at negative 3, put a check mark to realize I've done it, is there's a kiss. You're going to go close, you get close, you kiss and you run away. And then at x is 0, you're going to shoot through the x-axis. Shoot through it. You go through it. Does that make sense? And then at x equals 1, we're going to shoot through it as well. But here's the hard part. I need to shoot through it and get to that arrow. Somewhere over there. Okay? So, here's a big idea. Make sure it's factored. Draw yourself a basic graph based on its highest powers. Right? If you multiply all that out, it would be really big in standard form, but I'm just giving you a basic idea of a basic graph. The multiplicity, after you've done the zero product rule, is you're looking at its degrees. If it's an odd degree, it's going to go through the x-axis, shoots through the x-axis. If it's an even, you'll kind of kiss the x-axis or bounce off the x-axis.